Here we are with the Math 3 Unit 2A Polynomial Test 1 review. So, all these types of questions we're going to have on the test. Maybe not as many, but the same type of stuff. So let's get going on this. Make sure you have any notes with you. Pascal's triangle would be helpful as well. So remember, on these first ones, we're just adding or subtracting polynomials. So the idea here is that we need to have combined like terms, right? We combine the like terms, and then and remember, like terms have same variable to the same power, and then we write it in that descending order. So what's my highest power? So I've got a 4. Now, when we have subtraction, remember, the idea is that we are going to change this to add, and everything after it changes its sign. So 4 is my x to the 4th is my biggest, so I've got a negative x to the 4th minus x to the 4th. So it would be negative 2. X to the 4th. Now let's go down to our next. Our next would be x squared. So 3x squared, 6x squared, negative 6. So 3 minus 6 would be negative 3x squared. Then there's no other 3x's, so minus, right? Because I changed them all to minus. Minus 3x. And then the last one, positive 6, so plus 6. And I already did it in descending order, so that's simplifying the expression. Okay, number 2 now. Number 2 is addition, so just look for your highest. My highest is negative x to the 4th, so negative x to the 4th. My next is x squared, so plus an x squared. Then negative 6x, positive 6x, they'll cancel. Then 4 minus 8 would give me negative 4. And that's all there is to it on these ones. So this minus, change it to a plus, change every sign of everything. So positive 4x cubed instead of a negative. Highest power is x cubed, so 7 plus 4 would be 11x cubed. Okay, then I'm done with that. There's no x squared, so I go to x. X minus 3x, negative 2x. Then negative 3 minus 3 plus a negative 3 would be negative 6. Number 4, my highest power is 4, so 3v to the 4th. Okay. Then squared is next, so minus 3v squared. Then 7v plus 6v, so plus 13v. And then finally minus 2 plus 5, so plus 3. 5 minus 2 would give us 3. And that's all we're doing when we're adding and subtracting those polynomials. Okay. Now when we're finding each product, okay, we can use the area model, right? So in this first one, I've got 3p squared, negative 8p, and 7, and then 2p and 5. So on all of these, you can use the area model. On these bigger ones, you just have to make a bigger area model, right? Or you can use these patterns, okay, if they're squared. If they're not squared, we're using the area model, aren't we? And I was looking, I don't think we saw any that were squared, did we? Nope. So we have to use the area model on these ones because we don't have anything that's the same. So 2p times 3p squared would be 6p cubed. Negative 8p times 2p would be negative 16p squared. 7 times 2p would be 14p. 5 times 3 would be 15p squared. Negative 8 times 5, negative 40p. 5 times 7, 35. Then we combine like terms. There's no other cubes, so I go 6p cubed. Cross that out. There's two squareds, okay, a negative 16 and positive 15, so negative 1p squared. Then there's a negative 40 and a positive 14, so a negative 26p plus 35. Okay, and that's all we got to do. Just following that area model, okay? So I'm going to do number 6 down here where I have some more room. So same idea. I've got 3, so 6p squared, 7p, 3, and I've got 4p and 7. So 4 times 6, 24, p times p squared, p cubed. 4p times 7p, 28p squared. 4p times 3, 12p. 7 times 6, 42, right? 42p squared. 7 times 7, 49p. 3 times 7, 21. Okay, then when you look what matches. Okay, there's no other cubes, so I write 24p cubed. Okay, there's two squares, so 42 plus 28 would be 70, positive, 70p squared. 12p, 49p, both positive, so 61p, and then 21 is my last one. Okay, now on 7 and 8, same idea. The only difference here is that we are going to make our thing bigger, right? So 6a squared, doesn't matter if you put them on the side or the top. A squared, 2a, and 8. So a squared times 6a squared, 6a to the 4th. A squared times negative 5a, negative 5a cubed. Then 4a squared. Then these two, 12a cubed. Negative 5 and 2, negative 10a squared. 4 and 2, 8a. 6a and 8, 48a squared. With 5, negative 40a. And then 32. So then we look for the highest power. So 6a to the 4th. So I start out 6a to the 4th. Then I've got two cubes that I can add. So 12 minus 5 would be plus 7a cubed. Then I've got three squares. So 48 minus 10 would be 38. Plus 4 would be 42. So plus 42a squared. Then I've got two just a's, negative 40 plus 8, negative 32a, and then only one regular constant, so plus 32. And we're done with that one. Okay, so kind of a process going through it. But you just make that area model, also called the box method by some teachers, and we put it in. So 3x squared, negative 2x, 4, 6x squared, negative 2x, negative 8. Okay, so negative 32 here, positive 16x, negative 24x squared, negative 6x cubed, positive 4x squared, negative 8x, 24x squared, negative 12x cubed, and 18x to the 4th. Now I'm going to clear this out so I have space to write it down. Okay, so start with this, 18x to the 4th. Combine those two, negative 18x cubed. Combine those three. Negative 24, positive 24 cancel out, so positive 4x squared. Negative 8 and 16, positive 8x minus 32. And there's all our multiplication ones. Oh, except for number 9. Now remember, number 9 actually does follow one of our rules, right? Okay, we had the a squared plus b squared rule equals a plus bi times a minus bi. So it follows that pattern, so we need a and b. So a is 3x, b is 5. And then I just go 3x squared plus b squared. So I get 3 squared is 9, x squared is x squared, 5 squared is 25, and that's the one I have. Okay, which using that rule can help out a lot, can't it? Now with the next, we're still using those rules. Okay, it wants us to factor these completely, and that's including these guys as well. Okay, so we look at these and we're looking for, with factoring, do we have the difference of squares here, the addition of squares, sum of squares, difference of cubes, or the addition or sum of cubes? Because each one of those follows one of these patterns right here, right? Nope, not that one. Right here, one of these 4 patterns. Okay, so the first key is noticing what the variable is. So this is n squared, so 25 is what squared? Oh, it's 5 squared. So I've got 5n squared. 9 is what squared? 3 squared. So the pattern for these guys is that you just go a plus b times a minus b. Okay, if we go back to the pattern, that's what we got going on here. So I go 5n plus 3 times 5n minus 3, and I'm done with that one. Okay, 11, I've got a squared here, so it's kind of the same as this. So I'd have 5x squared minus 4 squared. So I'd go 5x plus 4 times 5x minus 4. Now I've got a cube here. Okay, so it'd be this guy, right? So a is 2 cubed plus x cubed. Now for the cubes we have a different pattern, right? We have a plus b, then a squared minus ab plus b squared. So I'd go a2 plus bx times a squared, so 2 squared would be 4, minus, we do the opposite here, 2x, a times b, plus x squared, which would be x squared, like that. And that's my answer for that one. Okay, now clear some space for 13. 13's the same one, right? So 4m cubed plus 32. Now I don't know what 4 cubed can't be anything, so I'm going to take a 4 out first and have m cubed plus 8. Okay, so it'd be 4 times m cubed plus 2 cubed. So that 4 kind of stays out. Then I go a plus b, so m plus 2 times m squared minus 2m, because a times b, plus b squared, which would be 2 squared, or 4. So it would be 4 times m plus 2 times m squared minus 2m plus 4. Okay? Sometimes you do have to take that out to simplify it. Alright, now looking at the rest, okay, this is another one. We're going to have to divide both of these by 2, so it becomes 2 times x cubed minus 125. So now we've got the subtraction. So subtraction, same idea, you start with subtraction and add. So we'd have x cubed minus 125 is really 5 cubed. So there's my a, there's my b. So it would be x, 2 times x minus 5 times x squared, because that's a squared, plus 2a times b, so 5 times x, plus 5 squared, which would be 25. And there's my answer for 14. Okay. 15, we've got the minus for the cubes, so there's a, that would be 1 cubed, would be 1, so there's my b. So I go a minus b, oops, so u minus 1 times u squared plus 1u plus 1 squared. Okay, and that's all I have to do. Now for 16 and 17, now we've got the pluses and the squares. So that's our special one. So we're going to put a plus bi times a minus bi. So this is really x squared plus 7 squared. So I go x plus 7i times x minus 7i. And I'm done. And that's all there is to it. On 17, 25 is like 5 squared, x is like x squared, so 5x squared plus 81 is 9 squared. So that equals 5x plus 9i times 5x minus 9i. So using those notes, those formulas, you can easily do a lot of these problems. Okay, now 18, 19, 20, and 21, we're just telling the number of terms and degree for each polynomial. Remember, the degree is the highest power. Okay, so highest power. And in terms is every time you've got variables, coefficients, powers, and constants. So if I look at 18, and basically look for pluses and minuses. Okay, anything in between is going to be a term. So 1 term, 2 terms, 3 terms, 4 terms. So there's 4 terms, and the highest degree is 3. So it's we often call that a cubic polynomial, but we could just say 3rd degree. For number 19, those are no pluses or minus, so 1 term, and it's k to the 5th, so it's a 5th degree. 21, there's 2 terms, and the highest power is 7, so it's 7th degree. Okay, 20, we've got 1, 2, 3, 4, 5, 6, so 6 terms. Now, don't always look at just the beginning. Negative 8n, that's not our highest power. Our highest power is actually 6, so this would be a 6th degree. So you gotta sometimes hunt for it. Okay. Now, these last ones, we're using Pascal's triangle to help us out. So we'll start with some easier ones. The first one, what is term 6 in row 9? So remember, we start with row 0, so then 1, 2, and notice 2, 3, 4, 5. So you can kind of go down and see, okay, so we want row 9. So here's row 9, because the 9s are right there. Now remember, we start with term 0, and then go term 1, 2, 3, 4, and so on. We wanted term 6, 5, 6. So term 6 would be 84. So that's all it wanted you to find there, that coefficient essentially. Okay, 23, what is term 3 in row 11? So let's go to row 11 right here. Term 3, 0, 1, 2, 3, so 165. Okay, now in 24 and 25, they're essentially asking the same thing as 22 and 23 did, but they're doing with that combinations idea, because that Pascal's triangle helps us with the combinations. So 8 students applied to be on the Spirit Week committee. If 5 students can be on the committee, how many different committees can be formed? So the total number of how many people you have, or other things, okay, that's your row. So we're looking at row 8. How many they can be split up into, so 5 students, that's our term. So I go to row 8 and look up term 5. So row 8 is right here. Term 5, 0, 1, 2, 3, 4, 5. So there's 56 different ways we can form a committee of 5 students out of 8 students. Okay, 25. 10 students applied to be Rydalch's TAs for next year. If only 3 students can be his TAs, how many different combinations of students could Mr. Rydalch have? So the total was 10. So we go to row 10, right there. Okay, and then 3, so term 3, so we go 0, 1, 2, 3. So there's 120 different combinations, different way to pick 3 students out of those 10 students. Okay, so those are the easy ones with Pascal's triangle. Now let's do some more complex ones. And we're almost done too. So we want the third term in the expansion of this. So remember, Pascal's triangle helps us with that binomial expansion. Okay, now on 26 and 27, they simply want one term to be included or found out. Alright, so the way we do this, we look at the power here. So that's 7. So that means we go to the 7th row. Okay, and we want the third term. So the third term, 0, 1, 2, 3. The coefficient is going to be 35. So it's 35, and remember we're thinking a plus b to the n. So a to the sum power, b to the sum power. So we always start with the highest power. A is always the highest, which was 7, because we're on row 7. B always starts at 0. So the 0 term would be a to the 7th, b to the 0. Then a goes down by 1, b goes up by 1. So the first term would be a to the 6th, b to the 1st. The second term, a to the 5th, b to the 2nd. And the third term, a to the 4th, b to the 3rd. Notice these exponents always add up to equal our power, which was 7, because we're on row 7. So we've got a to the 4th, b to the 3rd. Now we take our numbers, we plug them in there, and we simplify as best we can. So a would be y, b is negative 2x. So 35 times y to the 4th for a times negative 2x to the 3rd for b. So 35 times y to the 4th times negative 2 times 3 is negative 8 x cubed. Negative 8 times 35 be 280. So negative 280 y to the 4th x cubed. That would be the third term if we expanded out that binomial right there. Okay? So now we do it for 27. Same idea. Our power is 6, so we're going to be here at the 6th row. Okay? So we want the 5th term. So 0, 1, 2, 3, 4, 5. So it would be 6 right here. So now I could start here and go a to the 6, b to the 0, or I could remember that if we go to the last term, b has to be that highest power, a has to be 0. So I'd have a to the 0, b to the 6, which means if I step back 1, a would be to the 1st, b to the 5th. So 6 times a to the 1st, b to the 5th. Right? Yep. So then a would be v, b would be negative 2. So 6 times v to the 1st times negative 2 to the 5th. Okay. Negative 2 cubed was negative 8. So times by negative 2 would be positive 16. Times by negative 2 again, which would be negative 2 to the 5th, would be a negative 32. So 6 times v, because v to the 1st is just v, times negative 32. So negative 32 times 6 would give us negative 192, so we get negative 192 v, and that's the 5th term. Okay, now the last two are going to be the craziest. Okay, what they want us to do here is expand these completely. So now we've got to go through the whole process. So once again, we look at that power 3. So we're on the row 3 right here. So our coefficients, we've got 4 terms. Our coefficients are going to be 1, 3, 3, and 1. Okay. Now it's going to be a to the 3rd, b to the 0, plus 3 times a squared, b to the 1st, right? Start with the highest power. They both add up to 3. A goes down, b goes up. Plus 3 times a to the 1st, b squared, plus 1 times a to the 0, b to the 3rd. So then I take my a and my b, and I plug them in. So 1 times u cubed times negative 2v to the 0, plus, now we know anything to the 0 is 1, and we know timesing by 1 is useless, so I can just get rid of those if I really wanted to. 3 times u squared times negative 2v to the 1st, plus 3 times u to the 1st, negative 2v squared, plus, once again, that 1 and a to the 0 are both going to be 1, which timesing by 1 does nothing. U to the 0 is still 1. So I can just leave that b and go negative 2v cubed. Then we simplify. Okay. So u cubed plus 3u squared times negative 2v plus 3u to the 1st times negative 2 squared is 4v squared plus negative 2 to the 3rd is negative 8v cubed. Then we simplify and finish. U cubed plus 3 times negative 2 is negative 6. So let's just make that a minus 6u squared v plus 3 times 4 is 12u v squared. Then a negative 8, so minus 8v cubed. And that is my polynomial expanded completely. Okay, now it looks like we just have enough time for the last one. Sweet. So now we've got row 5. Okay, so I'm go to row 5, find my coefficients. So 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. Once again, I start with the a to the 5th, b to the 0, a to the 4th, b to the 1st, a to the 3rd, b to the 2nd. See that pattern? A to the 4th, b cubed, plus a. Oh, a should have been going down. I horribly botched my. That would be 3. So that would be 2 b to the 3rd plus a to the 1st, b to the 4th, plus a to the 0, b to the 5th. So you can kind of eliminate those two guys and those two guys. So a to the 5th. So my a is actually a. That's easy enough, right? A to the 5th plus 5 times a to the 4th times b is negative 3b, negative 3b to the 1st, plus 10 times a to the 3rd times negative 3b squared plus 10 times a squared times negative 3b to the 3rd plus, then we keep going, 5 a to the 1st, negative 3b to the 4th, plus just b to the 5th, so negative 3b to the 5th. And then all we want to do is simplify things. So a to the 5th is going to remain a to the 5th, right? We don't need to do more with that one. This one, a to the 4th, so 5a to the 4th times negative 3b. 5 times negative 3 would be negative 15, a to the 4th b. Okay, plus we get 10. I'm going to kind of erase some things as I go. So this one would be 10a cubed times negative 3 squared would be 9b squared. 10 times 9 would give us 90a cubed b squared. Okay. So then going down to the next one. So it would be 10a squared. Now negative 3 cubed is going to give us negative 27b cubed. So 10 times negative 27, negative 270 a squared b cubed. Okay. Then we've got 5 times a times negative 3 to the 4th is going to be a positive 81 b to the 4th. So 5 times 81 would be 405 plus 405 a b to the 4th, then plus, so 81 times a negative 3, which would be negative 3 to the 5th, would be 3, negative 243. So we get plus negative 243 b to the 5th. And there's our last expansion. So those ones are pretty crazy, aren't they? But this is all the stuff you need to know. Make sure you have any of those notes you'll need. Make sure you're ready for the test. Hopefully you were able to use this, figure things out. If not, you better come talk to me before the test if you have any further questions. So there we go.